If your organization must define your own attributes for use within your internal directories, you should consider obtaining your own private enterprise number ARC to identify these attributes. We do not recommend that you make up your own numbers, as you will probably not be able to interoperate with other organizations or some vendors' LDAP products, lightweight directory access protocol. This is not to say obtaining your own OID ARC from ISO or IANA or some other authority to define your own object classes and attributes will guarantee interoperability, but it will prevent you from using OIDs that have already been assigned to or by someone else. OIDs are only used for equality matching. That is, two objects, for example, directory attributes or certificate policies, are considered to be the same if they have exactly the same OID. There are no applied navigational or hierarchical capabilities with OIDs. Unlike IP addresses, for example, given an OID, one can not readily find out who owns the OID. Related OIDs, etc. OIDs exist to provide a unique identifier. There is nothing to stop two organizations from picking the same identical names for objects that they manage. However, the OIDs will be unique, assuming they were assigned from legitimate ARC numbers. If you are interested in obtaining a private enterprise number ARC for your own organization, you may apply for one free of charge at the Internet Assigned Numbers Authority website, http://www.iana.org/cgi-bin/enterprise.pl. For more information regarding OIDs, the trees of assigned numbers, and registration, we recommend starting at asn.1 frequently asked questions website at http://asan1.adebal.tm.fr/oid/faq.htm. Let us look at the following example. Top is an object class that contains the object class attribute. Person is a structural class that instantiates the directory entry for a given person, where the object class attribute is also part of that person entry. So far, this example has used only attributes and object classes defined in a standard. So now, you may want to tailor the people entries to include information that your company requires, and that is not defined in the standard person object definition. There are two ways to do this. Subclass the person object to create a new structural class that includes those additional attributes defined by your company and instantiate the personal directory entry based on that new class. Define that collection of company attributes needed for your company's personal definition as an auxiliary class and attach it to the directory entry instantiated from the person class. Either method is recommended. The downside to auxiliary classes is that if the auxiliary class includes an attribute that is also included in the structural class definition, when that attribute is included in the instantiated directory entry, and that attribute contains multiple values and you want to delete the attribute, you cannot tell whether the attribute when added to the entry was added when the structural class was instantiated or when the auxiliary class was instantiated. This may be important to the implementer or administrator. Special entries exist in the namespaces called aliases. Aliases represent links to other entries or partitions of the namespace. When the distinguished name of an alias is used, the entry accessed is the entry to which the alias refers, unless specified otherwise through the programming interface. The collection of directory entries forms the directory information tree, DIT. The method of storage for the DIT of the LDAP directory is implementation dependent and hidden from the user of that LDAP directory. For example, the ITDS uses IBM DB2 as its data store, but no DB2 constructs are externalized to LDAP. Attributes. All the object class does is define the attributes of types or types of data items contained in that type of object. Some examples of typical attributes are CN, common name, SN, surname, given name, mail, UID, and user password. Just as the object classes are defined with unique OIDs, each attribute also has a unique or ID number assigned to it. LDAP version 3 attributes. Following notation similar ASN. Dot 1. To object classes. Example 2-6 shows some attribute definitions. These are attribute definitions. Notice in example 2-6 on page 41 that the superior SUP of SN is the attribute 2.5, 2.4, 0.441, which happens to be the name attribute, but then the name attribute description says unlikely that the values of this type itself will occur. This illustrates just one of the many peculiarities of the way the attributes have been defined. It merely provides the shorthand way to define name-like attributes, such as surname. We did not need to define the syntax for SN because it inherits this from name. The attribute mail also has an alias of RFC 822 mailbox. As you may have guessed, the equality of syntax are yet more ASN.1 definitions. 2.3 The naming model. The lightweight directory access protocol naming model defines how entries are identified and organized. Entries are organized in a tree-like structure called the directory information tree. DIT entries are arranged within the DIT based on their distinguished name. DN is a unique name that ambiguously identifies a single entry. DNS are made up of a sequence of relative distinguished names, RDNs. Each RDN in DNS in the DN corresponds to a branch in the DIT leading from the root of the DIT to the directory entry. Each RDN is derived from the attributes of the directory entry. In the simple and common case, an RDN has the form attribute name value. DN is composed of a sequence of RDNs separated by commas. An example of a DIT is shown in figure 2-2 on page 43. The example is very simple but can be used to illustrate some basic concepts. Each box represents a directory entry. The root directory entry is conceptual but does not actually exist. Directory root C US O IBM OU applications OU people OU groups CN John Smith. Figure 2-2 example of a directory information tree. DIT. The organization of the entries is DIT is restricted by their corresponding object class definitions. Entries are named according to their position in the DIT. Directory entry at the bottom of the figure as DN of CN John Smith. OU people or BIBM CS is UN US. C is US. The organizational group people has the DN of OU people or IBM CU is US. 2.3.1 LDAP lightweight directory access protocol distinguished name syntax. DNSs entries in LDAP directory are identified by their names. The characteristics of these names are they have two forms: string representation and URL.